Hello, today I'm going to go through a mechanics question. It's from year 2, exercise 7F, and it's question number 5. I'm going to read out the question to you. So it says two particles A and B on back-to-back rough slopes are connected by a light inextensible string that passes over a smooth pulley as shown in the diagram. A has mass 2 kilograms and B has mass m kilograms. The coefficient of friction between A and the slope is 0.2 and the coefficient of friction between B and the slope is 0.4. Part A, show that the maximum value that m can take before the particles begin to move is 10 plus 2 root 3 all over 5 subtract 2 root 3. And part B, given that m equals 10, find the acceleration of the particles. Right, let's have a go at doing this. So I normally begin by drawing a force diagram. So here it is. Okay, so the two slopes both inclined at 30 degrees. There we go, and I'll just put in the two particles. So this is particle A and has got weight 2g. There's my weight triangle. And particle B, and that has got weight mg, and I'll put in the weight triangle for that. There we go. And then we'll have normal reaction for A. Let's put it in there. And we'll have a normal reaction for B. Put it in there. Now they are going to be different. So to make it simpler, I'm going to call it RB and RA. Okay. And we've got mu equals 0.2 for A and the slope, and mu equals 0.4 for B and the slope. Now we've got to make a deduction here as to which way it's going to go. Okay, so reading the question again, it says show that the maximum value that m can take before the particle begins to move is something. So the maximum value that m can take. So that implies that if m was any greater, it would start to move. So let's be silly, let's suppose m was 1,000 kilograms or something. Well, which way is it going to go? Well, it's going to go down the slope, isn't it? Because obviously we're talking about particle B for m, and if that is the heaviest one, it's going to go down the slope, which means that A in turn is going to have to go up the slope. So those are our directions that we'll be looking at. Okay, and that's going to be quite useful. Now I'm going to put in a couple more forces. So we've got tension, equal and opposite, of course, because they're connected by the same light and extensible string wrapped around a pulley. However, what about the friction? That's why the direction is important, isn't it? So for B, if it's going to move down the slope, then the friction will be in the opposite direction. It will be heading up the slope. Okay. And for A, if that is going to be heading up the slope as its direction, the friction will be down the slope. Okay. Now I'm going to call those FA and FB as well. Diagram's getting a little bit full now, isn't it, with all of that stuff going on. But there's your diagram. Okay, just rewind the video and play the important bits again if you need to fully understand more why the forces are as they are. Okay, but for now I'm going to move on. Now typically with these questions, that is connected particle questions, you need to consider what's happening with A and B separately. Okay, so what I'm going to do is I'm going to start off by considering what is happening for particle A. I'll just do that down here. The trouble is I'm going to run out of board space fairly quickly, so I'll try and do my best for you. So for particle A, if we resolve perpendicular to the slope, so just put in, oh, I hate it when that does that. There we go, back again. Perpendicular to the slope, so we've got R must be equal to 2g cos 30 degrees, and that is equal to root 3g. I'm hoping you're happy with that. Pause it if you just need to fully understand what's going on. Okay. And because of the coefficient of friction being 0.2, we know that F is equal to root 3g over 5. I'm going to write that as root 3 over 5g. Okay. Now, I've not actually labelled it R of A and F of A because I've actually said we're dealing with particle A here. So I'm just hoping that that is absolutely clear there. Okay. Well, what else is going on? Well, we're going to have to resolve parallel to the slope as well. So let's just do that. So parallel to the slope, we're going to have t is equal to 2g sine 30 degrees plus root 3 over 5g. Why is that? Well, you have to assume it's in limiting equilibrium here. It's not actually moving. It's on the point of moving. That is to say, for this value of m that we're going to calculate for b, it's going to be stationary. And we're working out a maximum value such that it is stationary. So because it is going to be stationary, then the assumption that you make is that the acceleration for the moment is 0. Okay, and so we have the forces balancing each other out on the direction parallel to the slope. So we must have t must be balanced out with the frictional force and the weight down the slope as well. Now I'm just going to simplify that a little bit. So sine 30 is a half, so that's going to be g plus root 3 over 5g. Okay, which you can factorise if you want. I just won't for the moment. So that's what's going on with particle A. Right, for B, let's have a look to see what's going on with particle B. Well, perpendicular to the slope, you must have r is equal to mg cos 30 degrees. And that's just equal to root 3 over 2 mg. And then using the coefficient of friction, F equals mu r, where mu is 0.4. That means that F must be root 3 over 5 mg. And then parallel to the slope, again for B, we must have a similar thing because we assume it's going to be in limiting equilibrium. We'll have the forces balance each other out. So T in this case must be equal to mg sine 30 degrees subtract root 3 over 5 mg. Okay, and I can just simplify that a little bit, can't I? Sine 30 is a half, so it's going to be half mg subtract root 3 over 5 mg. Now where to go with these? Well, it must be the case that these two tensions here, they must be equal to each other. Okay, remember that is one of our assumptions that we make, given that the pulley is smooth. If it's moving, the accelerations are the same for both particles, but also the tensions in the string are equal as well. So our next step is just to set these two expressions equal to each other. I'm going to try and keep it all on the same page. So I'm just going to start off by writing, so I'm going to divide up a little section here in a different colour just to make it nice and clear. So I'm going to set them equal to each other. So I'm going to have g plus root 3 over 5 g must be equal to 1/2 mg minus root 3 over 5 mg. And then quite nicely the g's are all going to cancel each other out, which is absolutely lovely, isn't it? Okay, that's absolutely lovely. What I want to do is I want to factorise the right hand side as well. So I'm going to have m on its own on the right hand side eventually, and I just want to get rid of some of these fractions. So there's a few things that I want to do in such a short space. I wish I had more space, but the fact of the matter is I don't. I want to multiply both sides by 10. Okay, I think I can just squeeze that line on down here. Okay, so what I'm going to do is at the same time I'm going to divide throughout by g and multiply throughout by 10. So I'm going to get 10 plus 2 root 3 on the left hand side is equal to 5 m subtract 2 root 3m on the right hand side. I'm hoping you're happy with that. Now I'm just going to switch the sides over and factorise. So I'll just pause there for the school bell. I don't know if you picked up that on the sound. So I've got 5 subtract 2 root 3, and then that's going to be equal to 10 plus 2 root 3. There we go. And if I just divide throughout, I'm going to have m is equal to 10 plus 2 root 3 all over 5 subtract 2 root 3. And we're done. That's part A. which is quite a lot for 6 marks, isn't it? Okay, but there you go. It's one of the reasons why it's a challenging question. Now, let's just do part B. Spoiler alert, the answer in the back of my textbook is incorrect. So if you've got the same edition copy as my textbook, you'll also find that's incorrect as well. So just hang on for a few more minutes and you'll see what the correct value for the acceleration should be. Okay. Well, so we're going to have m is equal to 10. Well, it does say that there's going to be an acceleration, but just for my own curiosity, I'd just like to know what our maximum value of m is that we've calculated. So I put this into the calculator, and that was 8.766 something. So as a value, that's more useful than the 10 plus 2 root 3, whatever. Okay. So 8.76, that's the maximum value of m before it begins to move. So the value of m equals 10 that we're given, well, that's clear in my mind now that B is definitely the heavier particle and it's going to be moving down the slope. Okay, I just wanted to get that clear in my head before I started with doing some of these calculations. All right. Now, what I'm going to do is I'm going to get rid of some of this working because I need to make space for answering part B. So just hum to yourself for a little bit while I'm doing this. I don't really want to hum to you. Humming is not my thing. Okay, but I appreciate that's a nice pastime for some people. I just fill up the empty sound with my various ramblings on. Okay, right, thank you for being patient. Right, so I'm just going to put in m equals 10 there. What am I going to do with this? Well, I'm going to sort out some equations for a and b separately. All right, so I'm going to consider particle B first of all. Now it's moving, so we're going to have to use F equals ma, where a is not equal to 0. Okay, so in terms of resolving parallel to the slope, I'm going to have the positive force first of all, which is the weight, mg, sine 30 degrees, and then subtract from that the frictional force, which if you recall was root 3 over 5 mg. Subtract the tension, I'll say a bit about that in a second, and that's equal to the mass times acceleration, m times a. And I'm just going to put in the m equals 10 there. Okay, so m equals 10, that will simplify to 5g, subtract 2, root 3g, subtract t equals 10a. And I'm going to label that equation 1. I'm hoping you can see where this is going. For those of you who are familiar with the connected particles questions, for particle, no, I don't want particle B, do I? I want particle A. Let's just make that correct. I've just done B, haven't I? So for A, I'm going to resolve parallel to the slope for this one. So A is moving up the slope, so the positive force is T, and then opposing that, so subtract the weight. So the weight component is this, subtract 2g sine 30 degrees, and then subtract the frictional force, 3 over 5g, and that's equal to 2a, and I'll label that equation 2. Now the thing you can assume is that because the surface is unchanged, the coefficient of friction is still the same, normal reactions are still the same, and in turn that means the frictional forces are the same as well. So you can still use the same values of F that we used previously. What is going to change though is the tension. The tension in the string will be different. Okay, if you think about it, if you start attaching higher and higher loads to a piece of string, there's going to be more tension. And what we're saying here is that the value of m, it's no longer the value of m, the maximum value of m we calculated in part A, the 8.7 whatever. It's something different. It's m equals 10. So you've got a higher load that is attached to this string, so that's obviously going to put more tension on the string. You can of course keep on adding greater and greater loads to the string, but eventually the string will snap because the tension force will be far too great for it. Okay, so just bear in mind these values of t are different, so you cannot just substitute in a value of m equals 10 into one of the previous equations that we looked at and use the tension that way. What I'm saying is the quickest way of doing this is to look at the whole thing again effectively and get the two simultaneous equations for A and B, and we've done that. Now Those of you well versed in doing this know that when you solve these, you just want to add the two equations together, because the tensions are going to cancel each other out, which is going to be absolutely lovely. So I'm going to have 5g subtract 2g sine 30 degrees, which is just g. So 5g subtract g, which is 4g. And I'm going to have negative 2 root 3g, and then subtract root 3 over 5g. And that can be written as subtract 11 over 5 root 3g. And 10a plus 2a is 12a. Now at this stage we can just put all of that into our calculator. Okay, so if you work out the left hand side and then divide it all by 12, you will get your acceleration 0.155 meters per second squared, and that's rounded to 3 significant figures. Okay, some of you might like to round to 2 significant figures because we're using g. Fair enough, that would be 0.16. Well, I just put in the 0.155 because sometimes when you're wanting to check, the extra significant figure just gets you to be a bit more reassured that you have actually got the correct solution. Right, so there it is. I hope you found that useful, and I hope you have a good rest of the day.